Welcome to the fourth episode in a series on the basics of engineering. The focus of this series is just to talk about engineering at a very conceptual level. I'm not diving into the math. I may get a few things a little off, but you can go to other references after you get this overview. So first episode, just talking about the different terminology. Second episode, looking at power, energy, and force. Last episode, taking a little look at forces and also torques. And so now we get to simple machines. So if we think about the word machine, we think about some mechanisms. Maybe we think about gears. We might think of appliances at home. When we think about the goal of a machine, it can do one of four things, or some combination of. It can transform energy from one to another. So if you remember in the previous episode, we talked about a transducer, which is converting different forms of energy. So whether you're talking about a battery, which is chemical energy, that can go to a motor, which would then go electrical. So really it's electromagnetic. That's really the hybrid to mechanical. Okay, and then so on and so forth. This motor could do a whole bunch of different things. You could transfer motion or forces. So this is probably would be done well with Legos, but you can imagine two different axles spinning, maybe in different directions. You can transfer energy. You can also multiply, gain either a greater force or a distance / speed. So if we think about riding a bicycle, thinking about gearing and shifting up and down, that's an example of gaining force, being able to go uphill, or gaining more speed. So that's an overview of what a machine might do. And we're going to talk about the 6 simple machines. So let's just list them out here. You can pause if you want to try to list them all out. But we have the lever, we have the wheel and axle, we have the pulley, and we have the inclined plane, we have the wedge, and lastly we have the screw. Now these are written out in a particular order. They're very much related. Sometimes people like to include gears, but gears are really just a bunch of spinning levers. And there's some really nice videos that will be linked to at the end that you can sort of see this in action. But let's just talk through the basics. So first we have lever, and we'll think about our typical seesaw. And there's 3 types of levers. A first-class lever, and these are just names, okay? We have the fulcrum, or the pivot, and then we have the effort, and then the load, sometimes called resistance. So this can come in all various forms. It can go on both sides. First-class lever. Second-class lever has the fulcrum on one end. You have, let's say, some sort of load. We'll just do L for load that you're trying to carry, and really this arrow should be going down. And then you have some effort. So a wheelbarrow is a good example of this, where you've got this big weight of stuff that you're trying to move. And of course in a wheelbarrow you have a wheel and axle down here. You have the effort of you lifting it up, but because you have this pivot, it's a lot easier to carry. In this case, you are saying, I'm going to give up distance, meaning I'm going to go a bit further away, but to be able to carry this load, which is a lot closer. And if you remember, we had the sum of the forces equals 0 when it's not accelerating. Same thing with the torques. The sum of the torques around a pivot, this, you lifting this up at this distance, should be equal and opposite to this weight at this shorter distance. All right, and then the third-class lever is just sort of the effort and the load flipped, where you're going to have an effort applied here, and the load is at the end. So this one's a little bit more nuanced, but actually your arm, if you have your arm here, all right, and you have the muscles All right, your muscle is actually acting at a point closer to your elbow, and then the load is whatever thing you're trying to carry. Tweezers, chopsticks, fishing rod, lots of different examples. All right, so you have a lever. And in general, the second class lever, you're trying to lift a heavier object, but you're sacrificing distance. In this case, maybe for whatever reason, you can only apply the effort much closer. So you're going to apply more of an effort in order to lift up some load that maybe isn't that hard to carry, but is further out. Okay, let's keep going. So we have levers. Let's talk about wheel and axle. So wheel and axle is really, if you think about it, a combination of two cylinders. So here I've got my wheel on the outside, and I've got my axle on the inside, and they share a center. So if you think about this axle fixed to this wheel, they are going to spin at the same speed. So you're able to spin this axle at a certain rate, and that's going to spin this much bigger wheel. And you can do the flip side around. If this is a steering wheel, you've got this nice big radius that you put work into turning, and that's going to be able to focus that torque around a center piece. And so really you can think of a wheel axle combo as levers, but in sort of a cylindrical or maybe circular form. Okay, so levers, wheel and axle. Then we have pulley. All right, what does a pulley do? A pulley, the actual pulley itself, sometimes they call it a block and tackle. It's something that is fixed. Maybe there's a pin here, this freely spins, and the pulley, part of the pulley is having a string. So let's say you have a weight here, and you're going to pull down with some force. And so let's say you want to lift up this weight to a higher height, you're able to pull in one direction, and because this changes direction, it's able to pull it up. Now, that's an example of transferring the force. But an example of a pulley where you can gain what they call mechanical advantage is when you have, let's draw this out here, you have a pulley here, and then your weight is like that. And essentially, and you can get into more detailed analysis if you want, you pull with that same tension, the force, and in this case, two amounts of the rope are pulling on the same weight. So in this first example, you only have one piece of the rope holding up the weight. In the second example, you have two pieces of the rope. So the effort that you give is half as much when you do the analysis. However, it goes through a shorter distance. So you have to pull at a greater distance, but it doesn't take as much effort. Okay, talked about the first three. Now let's talk about the latter half. Inclined plane, we talked about it with work. Okay, you have an object, you're pushing it up sort of a longer distance to get to that final spot. So you can make that trade-off. So if you think about ramps, that's what helps you able to move things instead of lifting it up to a certain height. A wedge is actually just two inclined planes back to back. And if we think about a piece of wood that you're trying to split with an axe here, okay, you can apply some force at the head here, and this wedge is going to then apply a force this way. This point sort of helps create that initial crack or fracture, and then you're able to split whatever you are trying to break apart. And then lastly, we have a screw, very important element. If you take this inclined plane and then you wrap it around a cylinder, kind of like a staircase, then you will get a screw. Now, screw and bolt, depending on your application, one term may be more appropriate than the other. But if we're talking about, let's say this is the bolt, and then we have that hexagonal, hexagonal. Okay, we have the nut, that's why they call it nuts and bolts. You're able to rotate this nut, and as you rotate it, it advances this way. Okay, so you can bolt two pieces of material together. So if we have a side view, let's say this is material A, material B, and you've drilled a hole, then you have a bolt, right, with the threads. And then you have this nut. I'm going to forego the hexagon here and just pretend like this is the nut. So because of the clamping force, you're able to hold those two pieces together. Alternatively, you can also have a screw. As it rotates, it can actually raise up materials. So there's the example of Archimedes and his screw that carries up water. Or you can just have a lead screw that's rotating and it advances something back and forth. So you're sort of going between rotational motion of the screw and whatever thing you're driving is the linear. And the useful thing for a screw is that you can't back drive it, meaning you can't, when you rotate the screw, it advances the piece back and forth, but you can't apply a force here to cause it to rotate. And that's because you have this winding piece of inclined plane that's going like that. And that's actually why you have things like worm gears. Right, so if this is a screw and you have, let's just draw a gear here. It is really hard to draw a good gear. Okay, but imagine that's a gear. Okay, you can have the worm rotate and that'll cause this to move, but you can't rotate this gear for the worm to move. Okay, so I think that's a good overview of our simple machines. Again, levers are just spinning gears. I'm sorry, gears are just spinning levers. And it's good to just sort of analyze. Don't get caught up on, oh, I'm identifying, is this a second class lever or a first class lever? Rather, think about where is the pivot, where is your effort, where is your load or resistance, how are we transforming energy, or are we transferring, or are we trying to trade off between force and speed? And once you get this mindset, this framework in place, then you are going to see simple machines all over the place. And know that these never really act by themselves. It's really a combination of different things. All right, thanks for listening.